beginning with this one, what we will notice is the first sketch that comes up, it draws the circle, and it's drawing the circle or ellipse where the mouse is. We can see the mouse on screen. We can see how the circle is tracking where it is using mouse X and mouse Y. This as code, it works, but what it is not is it is not flexible. And it does not follow this concept of using classes or object-oriented programming, which is what we want to work towards. Because when we construct our code as an object, like you did last week, where you created your balls or aliens or triangles or whatever your things were, you were able to then create a little piece of code that really you could now take that class and use it with any other sketch. And all you have to do is just say, all right, make a new ball and populate it with what you want, then call the balls methods. And if we keep our methods consistent of update and display, it makes it really easy for us to go through and have something that is portable from project to project. And the code is more tightly encapsulated so that the different pieces of code, when we change one thing, it is less likely to affect other things. So if we view this eventual catcher game that we're going to work on, we have an object that the player controls, the catcher object, and then we're going to have falling objects, the raindrops or whatever they choose to become, elves or angels or who knows, whatever you make. And then we need to have a few other utility things that are going to happen with this, and then we'll have a full functioning project. So right now, this is not very flexible. And the goal is we're going to turn this into using a class and build a class with it, and then we can now take and put some of that logic into it. So starting out, we can just say class, and classes, again, by convention, begin with a capital letter. And we always start out and we list our data first, and then we will have our constructor. And then we'll have our method. So we'll have these three components as part of each class that we build. Well, this class that we're going to be working on is going to have our X and our Y. Now it's possible that if you have data variables of the same data type, you can put them on the same line and separate them with commas, which when you start getting more complex, you're going to find that you may have a dozen or 24 variables as part of a class. And if you have certain ones that it makes sense to group together, like X and Y typically are shared values, so I would put those together. If I had a speed X and a speed Y, it makes sense I could put those on their own line. If they're all floats, I could put them all on one line, but if we kind of subgroup, it makes things easier to read and takes up a little less space, so it's easier to keep track of. And then I'm going to have my radius that I will be using with this. Now, being that this is a class, we begin our constructor line with reiterating the name of the class. And then I'm going to, as part of the constructor, we could hard code in the size of our catching object. But in this case, I like to build it so that I have the flexibility that if I want to use this with something else, I can just say, var catcher equals new catcher, and then specify when I say new catcher, specify the size at that point. So I'm going to put a parameter or argument that I'm passing in when I create this. And it will be my temp R. And we can start our X at 0, our Y at 0. And then the radius, I will set that equal to temp R. So I have my data defined. I have my constructor defined. And this is part of when you're building a class. These are all of the required elements. Now, with it being a class, we're typically going to need some sort of methods that are going to allow this object to then exist. Otherwise, there's really no point in doing this. So our standard 2 that we've worked with before of update and display makes sense as part of doing this. And just put a few extra returns so we raise it up on screen. So it makes sense to have my void update. And my void display. So the same 2 methods that we used previously. Now, update, as part of doing this, it took and updated the x and y values. So x is equal to, in this case, we want it just to be following the cursor, and y is equal to mouse y. So that now updates those values. Again, the reason for separating update and display into 2 separate functions is because I'm not bound to keeping my display always the same. I could update the position, but I could change in display. So it takes these same x and y values, but now it shows me something different. And if my functions are written this way, it makes it much easier to find that piece of logic, those lines of code that just control the display and update those without wrecking something else in the process. Now, it does make sense as you're doing this. Every object that you create in a class, you should specify information about its stroke or no stroke if it has no stroke, its fill or its lack of fill if it has no fill, because as you issue your commands for display for each of the objects that are going to be showing up on screen, you don't want this object to be affected by the fill commands for the others, because any time you specify stroke or fill, that will affect the stroke and fill for every other object drawn in your sketch until there's a different stroke or fill command. So it doesn't matter that it's in a class. So if I say fill 280 or 255, it stays at fill 255 until it encounters a different fill statement. So then if it says fill 128, then it will change. But if I've drawn 20 objects in the meantime, all 20 will be at that original fill statement. So fill is not tied to the object. Fill will affect everything that happens afterward until the program is told otherwise. So fill is like it's a global kind of statement. So that's why every object you're drawing, you need to explicitly specify the stroke and fill for that object. Otherwise, previous objects will affect that object. So I'm just going to give it a stroke of 0, a fill of 120. You can fill and stroke with whatever you want. And then I'll fill my ellipse, x and y. Then I'll do my radius times 2. Remembering that ellipse is now specifying the width and height. So if my radius is the radius or half the width of a circle, it makes sense then to use r times 2. And we're using radius here because when we start actually creating our objects that are going to be falling down, our balls that we're working with here, which eventually will become raindrops or something else, those objects, we need to know their radius to determine whether one object is intersecting another object. So that's why we're going to get in the practice of using radius here. So now I have a catcher object. It has its data, it has its constructor, and it has its update and display methods. So to go back to my beginning part up here, I don't need this stroke, fill, or ellipse anymore because they're really part of that object, so it can get rid of that. Now if I run this, I'm going to see absolutely nothing except a blank screen because I have not instantiated or created an instance of this class, and I have not then provided any instructions of what to do with it. So to make an instance, I will say catcher, and notice differentiating by the capital and lack of. So the class has a capital as part of it. My instance, I'm using lowercase. If that confuses you, you can come up with a different naming scheme that works for you. So if I wanted to say, well, eventually I'm going to have baseballs fall from the sky and I'm going to have a glove catching them because they're thinking of the April 1st Twins opener and you're all excited about that and baseball's on your brain and spring training just started and it's all exciting. So maybe you want your catcher to be a glove. But I'm going to use catcher for mine. Then to populate that, I can say catcher is equal to a new catcher, and then we have to pass in the number that we want. So if I want this to match what I had previously on it, then I would pass in a radius of 32. Because before I was drawing 64 pixel wide circle. So now if I run this once again, I'm going to see nothing. Because what I have not done is I have not issued the command to say catcher.update and catcher display. Now if we don't put the update in and just put display and run that, we'll see it drew my circle at 0, 0. But my x and y, because I'm not telling the catcher to run the update function, so I'm not saying update the x and y to the mouse x and mouse y, because that's never been called, that didn't take effect. But if we say catcher update and catcher display and run it, we're back to where we were before. So all of that work to get back to where we were before. Now, on the surface, on something this simple, it seems, well, that's a waste of effort. But know that I can make this catcher become anything else that I want by changing what's in the display or changing some of its constructor functions. So if I want to replace this so it's no longer just a circle, but I'm using an image, I can now add that into this class, and I don't have to change my main sketch one bit. I can now just say draw the catcher, and the catcher knows, oh, well, now I'm not a circle, I'm an image, and I need to draw this image at this location. Well, it will have its own logic of how to do that. So by separating the main program from the object, that gives us much greater flexibility as we're going to increasingly ask for better and cooler results. Moving into the timer. So currently, the way that we can use the timer object in processing is that we have a millisecond function, and the millisecond function is the time when the sketch starts running. Now we have access to other built-in date functions if you're so inclined. But the one that's most useful from a standpoint of doing interactive or game programming is to access the milliseconds. And we grab the milliseconds of when the sketch has started running, and we compare that to the current, so that if the sketch starts running and it runs for 1 second, and then we issue the command millis again, which is grab the milliseconds, after 1 second it will return a value of 1000, because 1000 milliseconds is 1 second. So what this sketch currently does is says, hey, when the time is at 5000, which would be 5 seconds, then at that point we want to say 5 seconds has passed. And then what we can do is we can update start time to whatever the current time is, so then it keeps running. So if I run this sketch, we will see that it does print out a message where it will keep saying 5 seconds passed, 5 seconds passed, 5 seconds passed. So I'm going to, every 5 seconds, change the background color to some random amount. Starts at black. And after 5 seconds, it became like gray. And it keeps going. Now, theoretically, you could go 10 seconds and see almost no change if you get two values that are real close to each other or virtually the same. But with this, if I want it to happen more frequently, I can just change my total time or my max time or my interval time or whatever I want to call it to a different amount. So if I said every second I want it to change, and now I run this, we'll see that it comes up, and every second it now starts strobing into a new value and a new value and a new value. So it keeps changing itself every second. So the key things that we're working with on here is we are trying to figure out, okay, here is how frequently my total time I want my timer to tick or to turn over. Then we have to figure out what is my starting time. And then we have to determine how much time has elapsed, how much time has gone by. So every time you issue the millisecond command, it says how many milliseconds has the sketch been running, and it gives you a value. So we can keep computing that elapsed time, and when elapsed time is greater than total time, then we can fire off a message at that point. So that's really the gist of it. Now this timer object, as we work with it and have to do these calculations, in some languages, like ActionScript or JavaScript, you can effectively do a set interval call. So JavaScript has set interval where you can say, okay, at this interval, and you say how many milliseconds you want, then call this function, and that function will have whatever you want to have happen. There's a newer feature called request animation frame in JavaScript that allows you to have greater performance with that, where it will work a little bit smoother and faster for animation purposes, thus the title, request animation frame. ActionScript has a full-featured timer, which can give you the timer event, the ticks of the timer. It can tell you when the timer is done. It can do all kinds of really fancy things, and you can write that logic into it, knowing that we have the ability to say how many milliseconds has this sketch been running. And that's what we're going to do, is we're going to make a timer object. We're going to actually take this timer code that's here and wrap this and build this into an object so we can say, hey, when is the timer done? And we can now issue that command so that we can then access the timer and work with it, so we can use the timer to control events within our project. So instead of just having things happen based on frames, we can now make things based on the timer. So we can, for that matter, you could set up multiple timers to control multiple activities going on within your project. And it would be perfectly happy to do so. So the same way that we build everything else into a class is what we're really going to work on doing here. So we're going to try and build this timer into a timer class. So starting out, we build it the same way that we always do. Class timer. And we'll have our data. Then we'll have the constructor. And then we'll have the methods that are part of this timer. Now this timer is probably not going to have the same update and display methods that we have with our animated or our visual objects, because that's not really what the timer does. The timer is in many ways a little bit more of a utility class, so that we can use it to do things. Now the data that it's going to need is going to be the same data that we used before, where we have our start time and we'll have our total time. So that will be the data that we will be using. Now the constructor will be our temp total time, because when we create a timer, we're going to tell the timer how much time we want the timer to run for, the total time. So then we can tell the timer, okay, that's how long I want you to exist. Now, methods that our timer is going to need, we probably want to be able to tell the timer start, and then we're going to want to be able to query the timer and say, are you done yet? Those are the two events, or the two methods that we will be looking for in this timer. So when we tell a timer to start, we'll just tell it to start. And then the start time will be equal to whatever the current milliseconds are. So we can say, hey timer, why don't you get going? Do something for me. Which, starting a timer is great. You can push the start button on your stopwatch, but at some point we need to know when it's reached its final amount. Now, to do that, we're really going to be utilizing what we had previously in our draw function up here. So where we had our elapsed time, and then we're comparing elapsed time to total time. So we're really going to be using what was up there with a little modification. Now this particular method of the timer is not going to return void. It's going to be returning true or false, because we will be asking the timer, are you done? And it will have one of two answers. Yes, I'm done, or no, I'm not. Yes being true, No, I'm not done being false. That means it is returning a boolean value. And don't need that. So is finished is a value that it can return. So we can tell the timer, are you done? We're going to ask it, timer is finished. Question mark, are you done? Now, I'm reusing some of what was there, but we're not changing the background here because the timer shouldn't be interested in changing the background. All we care about is if the timer is done, we will tell it to return true. Otherwise, we're going to tell the timer to return false. So we check for how much time has passed. If the amount of time passed is greater than my total time for the timer, send me true. Otherwise, send me a false value indicating we're not done yet. So we have a timer object which has a start and it has an is finished. Now if you're real enterprising, you could add in and build up extra timer methods that, if you've worked in some languages where you do have access to a much more granular control of your timer that you want your timer to do more, like an action script, then you could actually build a full complex, much more robust timer class. But for the purposes of what we're doing, this is going to work. So now I have completed the timer class. Has its data, has its constructor, it has a start method, and then it has its finish method that will then return a true or false value. Returning back to the main part of the sketch, not my class, but the main sketch here, as I look at that, this isn't doing much for me, and we'll want to change things around a little bit. So now I don't need these values up here. So I'm going to have a new timer. And then I'm going to have a value which is my end time. So I have my timer and my end time. So now if I run it, I won't have any error messages, but nothing magical will occur yet. So end time is when I want this timer to be done. We can say end time equals, and it's measured in milliseconds. Now, if I wanted to build this so that I did all of my times in seconds, not in milliseconds, we could easily do that with a little tweak in our code. So I'm now going to set up end time to be 2000 for this. And I'll say timer is equal to new timer. And I'll just pass in my end time value. And if I save this and run it, well, see, absolutely nothing happened because I never told my timer to start. But I also have never asked if the timer is done, and once it's done, I've never said to do something at that point. So what we could do is say timer start. by issuing that command by saying timer.start, we're accessing the method start within the timer class. So this instance of our timer object, we're telling it to begin running. Now inside my draw function, this is where we can make something happen. So we can say if the timer is finished, so we're asking that method, and to write this out fully I would say equal true. So if timer finished is equal to true. But when you're writing out a conditional statement, that is the same value. If it works better for your brain to say this, where you actually explicitly say is equal to true or is equal to false, I would encourage you to do so right now. Know that the longer that you type code in on the computer, the less you will want to type, so you will want to get out of that habit eventually. So now we can say, hey, if the timer's done, do something. So at this point, it's do something. And a real easy do that we could do is we can just randomly change the background color. So after 2 seconds, because we put in a 2 up here, so after 2 seconds, my background color should update. And it did. And notice after 2 seconds it updated, and it kept updating, and it kept updating because we never told the timer to start again or do anything else. So timer finished is true. So now 60 frames a second, we're getting a new background color because timer is still done, is still done, is still true, still true, still true, because it's been done now for 2 seconds. So if we want the timer to effectively reset itself, we just call out the timer start again. So now every 2 seconds, it will go to a new color. And if I want it to be half a second, use 500. We can see it cycles through. So if we do not issue the command to tell the timer to reset itself, then this conditional statement will stay true, and then it will just keep doing whatever is in that statement. So what we've constructed here is a repeating timer loop. But when it's done, we tell it to start over. Looking at the intersection class, that's where we're going to be. First, our objective is to intersect a couple balls. We'll have 2 starting out, and then you could easily add 3, 4, 5. Or if you're motivated, you could put 100 in if you want, and not use a for loop if you're a masochist. But you can do whatever you want. So currently, if we look at this, it's set up where the ball class is stubbed out for you. I was feeling generous at that point and I just didn't want to waste the class time putting all of that in. But I do want you to spend a little bit of time. If you look under ball where it has its update and display, what we want to have happen is we want these balls to bounce around on screen. We're not doing a gravity-based one at the moment. We just want the balls to bounce around. So a couple things that you'll need to figure out how to put in is dealing with your speed x and speed y, dealing with the x and y's, and then in your display, make sure you specify stroke and fill before you make your call to your ellipse. And this is going to use ellipse the same way we used ellipse in the catcher, where we use x and y and radius. So if you're feeling really clever, you might notice that those 3 lines of code will probably go very nicely inside the display for your ball. Your update, you need to update the x and y based on speed x and speed y, and then you need to deal with the boundaries when I hit the left or right, when I hit the top or bottom, and change my speed x or speed y accordingly. So I'm going to ask for you to go and put that into your code right now. So as we've done before, update x and y by the speed x and speed y. Check to see if the x's hit the borders with or 0. If so, change speed x. Do the same thing to y. If y's hit the bottom or the top, invert speed y, so times it by -1. That's updating. Display is stroke, fill, and draw the ellipse. And then you just need to make certain that in your draw loop or draw function, you tell each ball to update and each ball to display. So the next task, and if you're not 100% on your balls animating right now, don't worry too much about it. We will get yours working properly. But we're moving into the whole name of the file. The name of the file is called intersection. So what we really care about is figuring out when we have these 2 ellipses intersecting. And what we're going to do to pull this off is we are going to compare their center points with their radii. So this is why we constructed our balls using a radius value versus a diameter value, is so that we would be able to use this to our advantage. So what we want to know is when these 2 balls are intersecting. And the trick on that is determining from their center points if the distance between where these 2 balls have been drawn is less than the sum of their individual radiuses or radii, then that would indicate they are overlapping. Within processing, if I want to know the distance between 2 points, all I have to do at that point, I'm going to just write some garbage code right now. It's not real code, as we just I'm going to write my way through it and then convert that from plain language into code. But processing supports the function that we can use is I just say dist, and then it's x1, comma, y1, comma, x2, comma, y2. So that function, if I pass in the coordinates of my first point, the coordinates of the second point, it returns a value. So it knows what that value is. So I don't have to bother with taking the square root of the sum of the distance between the x's squared and the distance between the y's squared added together. I don't have to mess with any of that Pythagorean stuff. So now that we can see that the distance function is built into processing, which is really cool. And I knew that, I forgot that. I wrote a bunch of programs. I even made a utility class that could do some math things for me. One of them was calculating distance. And then I felt really silly afterward, realizing that someone had already hard-baked that into the language, and I didn't need to do that. But that's all right. So what we need to figure out is when these things are intersecting, we want to do something about it. And we can write that into a function. So we can actually say, and we can pass into it the appropriate values to find out if they're intersecting. But first, we're just going to kind of write out what our different things are and then get them into the correct code places. So if I start out with float d is equal to the distance, and the distance is really going to be x1, which would be the b1.x, and y1 is b1.y, and then we have b2.x and b2.y. So if you're trying to type along with this, I would encourage you to just hold out, because everything's going to be juggled around, moved around, and adjusted. So just watch what's going on first, and then we'll see the code left behind once all the magic has occurred. So that gives us the distance. And then we're going to have another value that I'm going to need access to on this, where I'm going to need float, and I'll call it r1 is equal to b1.r. Because if you remember, when a ball was constructed, it has an r property. It has an r piece of data associated with it. So when we make a ball, it has that r value. And the reason I'm putting these into variables will become apparent when we write this into a full-featured function. So in plain language, the balls are intersecting when d is less than r1 plus r2. So when the distance between the center points of the two balls is less than the sum of their radii, then the balls are intersecting. So that's the gist of the code. Now it's a matter of figuring out how to put that into language that makes it usable. So that if we notice along with this, we have these values that we can construct this in a couple of different ways. We can just put this in initially, not even as a function. We'll just add it in our draw. And this is going back to that iterative coding model. Get something working, then make your code optimized, then clean it up, then put it into functions, then put it into classes, versus trying to do all the super organized way of working in the beginning. If you just get code working, it's much easier to refactor it into a cleaner, more optimized form. If you start trying to build it in that more complex structure, it often will blow up in your face until you get used to it. And then what is complicated now will seem easy, because then you're aiming for even more complex kinds of code structures. So let me just look here. All right, I have to do a few other things so we can see something. So when they intersect, we're going to just change the background color for now, and then we'll go through and actually change the ball color when they're intersecting, because that's a cooler effect. But for now, it will be simpler to change just the background color as part of it. So with that, you can build it into an if statement. So these, if I have those variables up inside, and then say if, oh, already have it right here. So if the distance between the two balls is less than the sum of the radii, we want something to happen. So that's something I want to happen. At this point, we could say if I change my background to black when they intersect, else Now, if you notice, I have a background of white occurring on the first line. So if I leave that there, then even though I changed the color, it's going to then fill it again with white, and then it's going to draw the ball, so I will never see if they're intersecting. So we can disable that line for now and run it. And it would make sense to actually put all of this first. I was suspecting that, because I'm filling the background after I draw the ball, so I never actually get to see the balls move. So we can see when they're intersecting, the background changes color. And it works based on their circle dimensions. So do the background, then draw the balls. Otherwise, this background statement occurring afterward covered up what was on screen. Now that I have this working, it's going to be more fun to build this into an intersect function that I can just call. So my intersect function, I want to know, are they intersecting? That's a yes or no, true or false. Therefore, it returns a boolean value. So I will ask, are they intersecting? And then if they are, we will send back a message. So do some returns to get it up on screen here. So it's going to be these values here we will be playing with. And I'm going to leave that there because that will be if they are or not. And then if, so if it's true, return true. So I've skipped the hard part so far. We have to figure out how to get those values in, and I've skipped what to put in my conditional here. And I've done that intentionally because we'll get to that in just a moment. Now this will be if intersect is equal to true. And you can just say if intersect with the parentheses. So if intersect is true, we change the background color. So currently, as it's set up, it's getting very close to working. But when we say if intersect, what we really want to be able to say is what, if what is intersecting. So we need to pass some values into this to make it happen as part of it. So our intersect, as we are going to write it, we're going to send the objects themselves. So this is a deviation from what I'd prepared for the lecture. This is a deviation from what's in your textbook, but I think this is going to be a nicer little piece of code, so that's what we're going to try. If it doesn't work, I'll go back to the other one that was there. So we're going to say pass in if ball 1 and ball 2. So we're just saying if intersect and what objects. Now, when a function is set up to accept arguments, so we're passing in those arguments, it has to then be receiving those arguments. And it's going to be, and because they're called B1 and B2, which I wish I'd named them ball 1 and ball 2 so I could use B1 and B2 here, I'm just going to call it O1 and ball O2. So we're going to pass those in. So this is, I'm asking that function intersect to accept ball 1 and ball 2, and then it will if I just change all my O's to B's, I think it's going to work. Now if D is less than R1 plus R2. Now I'm using O, my mental model I'm working with as object, because eventually I might want to make this function so that it's even object dependent, so it doesn't necessarily, I could pass in different kinds of objects or classes, but we'll start out with ball here. So when we pass an object in, then that object, we can say that object which we know has an x, we know it has a y, and we know it has an r, so we can go grab its properties. The nice part about this function as it's now written, I could pass ball 3. I could pass ball 4, ball 5, ball 6, ball 10 if those objects existed, and this function would then compare the values of those objects. So if I had more balls on my project, I could now be comparing them to other objects. So the goal that we're trying to do here is to make the code more flexible. So if the balls are intersecting, change the background color. My intersect function returns a true or a false value. And if I'm lucky, it works.